And now we'll switch gears into a much faster-paced talks. We're going to have lightning talks. 3 lightning talks are queued up. The first one will be Doug Madory from Renesys. He'll be talking about new fiber coming online in Cuba and some interesting observations they made about it.
Hi, everybody. So I am, again, Doug Madory, analyst with Renesys. And so in my job at Renesys, I keep an eye on changes in internet connectivity in countries all over the world. One of those that I got interested in about a year ago was Cuba. I had read the story about how they had this cable built a couple years ago, and nobody knew what ever happened to it. It had never been activated. The government would never speak about it. And so I set up something to clue me in if we ever saw something, send me an email if we ever saw some evidence that this cable was in use. And a couple weeks ago, that email came. So taking a step back, so a little background on this for people who didn't know the situation. So up until very recently, Cuba has been entirely reliant on satellite internet due to the fact that they don't have a submarine cable going to their island nation that connects them to the global internet. So in about 2007, the state telecoms of Cuba and Venezuela got together and they announced plans they were going to build a cable from Caracas over to Cuba and try to solve this problem. The project experienced a lot of delays, but eventually in February 2011, Alcatel-Lucent completed the project. But since then, in about 2 years since that occurred, there was no evidence of any improvement in internet connectivity, what there is in Cuba, and then there was also no explanation from the Cuban government as far as whatever happened to this cable. So that all changed a couple weeks ago. I actually had set up in market intelligence as one of our products. I set up, let me know if there's any new provider that shows up for Atexa in Cuba, and so I got an email one day. I went and investigated it, and we looked at this graph is kind of a visual timeline of trace routes and latency measurements going into Cuba that helps follow the sequence of events here. So on January 14th, we saw the first evidence. Both routing, Telefonica showed up as a provider for Atexa, which is the state telecom of Cuba, and that in and of itself wasn't evidence of activity on the cable. What was really the smoking gun was the fact that we were seeing latencies around 300 to 400 milliseconds. So there was a gentleman earlier was making a comment about how you can pick out satellite latencies, and they are like on the order of 480 to 500 milliseconds. They really can't be any shorter or lower than that due to the laws of physics. And so when we saw these latencies at 400, we knew this could not be, it couldn't be satellite in both directions. And so then we, I think on January 20th, we published a blog detailing these, what was our discoveries. We theorized that likely like 400 milliseconds was still quite high if they were really using the submarine cable. So our speculation was that these guys at Atexa had set up they had a default route. They probably, whatever was their cheapest satellite provider, they were sending everything out. All traffic was going out, their cheapest satellite provider, and then all of a sudden you could come in a new way, a new path via Telefonica. And so there was some asymmetric routing going on, and that would explain why you had a very high but not high enough latency to be consistent with satellite. So that was our theory, and then it was interesting. So after we published this blog, we started to get some media attention. So we were getting calls from reporters. We did stories with the AP, Reuters. I did an interview with NPR. And as the story started to get going, then I got a call on, I think, January 23rd from the Reuters bureau chief in Havana, called and he said, hey, we've got an IT guy in our office, our IT support guy. He's Cuban, he doesn't speak any English, but he's telling us that something just happened about an hour ago. And I was like, oh, really? And he's like, yeah, it looks like things have improved again. And so while I was on the phone, I'm writing in our IRC at work, like, somebody pulled data from Cuba right now. And before I was able to hang up, and we're like, yep, we're seeing a drop across the board, as if they changed their default route. Instead of going out a satellite, to go out the cable. And so now the satellite providers now dropped to something that was more akin to an asymmetric satellite link, where you'd come in satellite and go out the cable. Anyway, so we wrote another blog about, hey, look, there's an improvement. Looks like they actually perhaps resolved this, so maybe we were correct in our theory. And then what was nice was, just to put a bow on a nice week, was the Cuban government actually came out and confirmed this story. I didn't think we'd ever hear anything from these guys, but you know, the following day after following day after the second blog, this is the Cuban Communist Party news outlet put out an announcement saying, yes, since January 10th, we've been testing the cable, and then they also put in a little caveat or a warning saying, hey, just because we're getting this cable going doesn't mean they're going to increase access to internet in Cuba, which is highly constrained. So that was nice, nice to get that confirmation. And then I'll wrap up my lightning talk here with, you know, internet measurement can have real impacts. This lady, Yaoni Sanchez, became our best friend that week. She was kind of tweeting out anything we were saying. We got a lot of response from folks, the Cuban, people in Cuba were sending us trace routes just to confirm, you know, what they were seeing for traffic. So that was a fun week. Does anybody have any questions? Thanks.
The next talk will be by Richard at nLayer. He'll be talking about Juniper BGP convergence.
If the slide decks look similar, it's because I stole them from Renesys, so thanks, Todd Underwood. So I'm talking a little bit about Juniper BGP convergence. There was a problem. Some of us have seen it. I've talked to about 30 people at Nanogs over the last several years who have seen this issue. Basically, what we would notice is for long periods of time, like 20 plus minutes or more or less, depending on the load, there would be a point where route installation on any Juniper router would stall. What you would see is you would see routes go into the pending state, and they would just stick there. And then eventually, after some number of minutes, something magic would happen, the stall would clear, everything would just install quickly. We've literally been saying this for many years, and we've been working with Juniper, everyone from small networks to, not small networks, like medium-sized networks to very large networks have been saying, we see this is an issue, and they haven't been able to reproduce it until now. So here's how I managed to reproduce this for them. What we did, we took a MX480, just modern box, MPC uplinks, doing no traffic. It's literally doing nothing but BGP. Top of the line routing engine, so the quad core 1.8 gigahertz with 16 gigs of RAM that you can buy. And we set up a normal iBGP mesh for us, which in this case, to reduce the load is not that big. It's 28 iBGP sessions across 4 different BGP update groups. It was about 4.8 million paths in total that are being fed into this box. Just a pretty standard, if you run a network and you've got iBGP, this is what you'll see. And we threw on 3 simulated full tables to try and replicate it. The point being, this is not even close to a real network load. This is just the bare minimum that you can get. And here's what we see. So this is kind of hard to read on the screen, but basically what you're looking at, the red line is the total paths on the box. The green line is the number of routes in the pending state, and the blue line is the number of routes that are actually installed into the FIB. So what happens, you see that the box does not get a full FIB table for, what is that, about 6-7 minutes? But the interesting part is that for the first 6 minutes, it doesn't get any routes at all. And the question is why? And the next thing is, how come it clears as soon as the total paths maxes out? So here's what we figured out happened. The scheduler inside RPD gets so busy processing BGP routes that are coming in from all of its neighbors that it can't actually install the routes to the fib, which I think is a bad thing because I like my routers to forward packets. Once you finish receiving all the routes, and this graph isn't even accurate enough to show it, but it's an instantaneous drop. It starts, the pending routes go away. You can now devote some CPU time to actually processing the routes that you've received, and you can start installing them to the fib. So we did a little work with Juniper, and we got them to test something that we think is the correct fix for it. Basically what this does is it tweaks the scheduler priorities a little bit so that instead of being completely blocked by receiving the routes, you also take a little bit of time to actually do something with them. So it doesn't really improve performance by a ton, but you at least don't sit there with no routes in the fib for 5-6 minutes. And remember, this is a lab scenario. In real life and in anything less than a top-of-the-line routing engine, what you see on a real network is 20+ minutes. You try this on an EX8200, it's literally like an hour and a half. It's ridiculous. But so the fix, you can see, it slows the overall convergence a little bit because you've now got to do more context switching, but you actually start to install the routes. Sounds good, right? Here's the problem. Oh, I guess this is the slide that just explains everything I just said. Here's the problem. They don't actually want to fix it. They don't think this is an issue. So what they told me was to go out and find people who think that this is an issue and get them to say this is an issue and we want someone to solve it. So if you would like your Juniper routers to install routes into the fib in less than multiple tens of minutes, go talk to your Juniper account team, tell them PR 836197, and tell them that you think this is a serious issue that they should pay attention to and resolve. It's been going on for like 5 years now and no one seems to care. Thank you.
And the final talk of the lightning talk session will be Lee Howard again. This time he'll be talking about IPv4 address consumption.
Hi, remember me? I was here recently talking about the cost of running dual stack, and that was coming from the talk, the cost of carrier grade NAT and the cost of addresses. I've been talking an awful lot about cost because that's sort of the way I think about the trade-offs that engineers have to make on building networks. Now it's, all right, so there's this address market. Who are the potential buyers? I have to be very clear. This is not Time Warner Cable work. I am not signaling strategy. If somebody knows our strategy, let me know. So the motivations for this, for the work that I'm doing here, is I wanted to say if the total cost of ownership of carrier-grade NAT is so high that people are going to buy addresses instead of doing CGN, how high will demand be? Well, let's go look at where demand might come from. Let's go look at the largest networks and see how much address space they have and how much address space they need. Now, I looked at the largest residential ISPs and content providers and a CDN or two. I really wanted to get to the transit providers, and I apologize for the fact that I wasn't able to get that included in time. My shell scripting foo is weak. Here's what I did for the residential ISPs, the 4 largest residential ISPs. I will name names. I downloaded the route views table. Cool stuff. I did some grep. That's probably not the grep command that I used because there are lots of switches in the order, and yeah. So I did some grepping. And then I did a show me from the Aaron who actually is the registered holder of this address space because I wanted to make sure that I excluded customer routes. So if you're running a network and you're originating a route for your customer, but it's actually their address block, that doesn't get included in how much address space you hold because you can't assign that to somebody else later on, right? Then I also did a visual grep to make sure that I was excluding that, and I also made sure that I included the subsidiaries that I knew of. And I'm specifically, in this case, I knew of several subsidiaries of Verizon, including the ones listed here. Now, the other thing that I looked at is the current number of residential subscribers for each of these ISPs and their growth rate. I looked at the 2011 annual reports. So this is old. It's 2011 because the 2012 annual reports aren't out yet for all of them. For many of them, and they certainly weren't when I was actually doing this analysis. So that's where this comes from. This is all public data. You can reproduce this. You can do your own analysis. I ask you please to do this kind of analysis because I can't believe that I'm the only one who's thinking about this. Ready? Shazam. It's a lightning talk. So if you work for one of these 4 companies, you're looking at the column. Everybody else is probably looking at the rows. So we start with how many addresses are routed by each of these companies. AT&T has roughly 80 million, 70 million, 30 million, 28 million. Those are millions and millions of addresses routed by these companies, originated from their ASs. This is based on route views, on one particular day that I pulled for route views. From their annual reports in 2011, they had this many millions of customers in residential internet users. Their 2011 growth rates. Okay, now we start to say, well, I'm trying to get at how long do they have before they run out of addresses and might be potential buyers of address space. 2011, AT&T's annual report, I read it twice. It said they lost 5 million residential users. Well, okay, if you're losing 5 million users per year, you're never going to run out of IPv4 address space. Comcast looks like they have a significant number of addresses compared to them. I mean, they had a significant growth. Wondering where those 5 million went. So Comcast had a significant amount of growth in 2011, but they still have a significant number of addresses, and so it's going to be some time, potentially, before they run out of address space. Now, the other two, there's a lot of variability in here because you start to wonder, what's the utilization ratio, right? That's the real question is, how many users per address do you get? Or how many addresses per user? For a residential subscriber, you could probably assume each residential subscriber, assuming native IPv4, each residential subscriber gets 1 address. But you don't know about, so what's the aggregation level within each network and what's the full ratios there. So I kind of took a swag and made some numbers here. Please feel free to do whatever you want to with that information. It's really important that I highlight the information that I didn't include. I excluded voice customers and video customers because even though they might be numbered out of public address space now, they might not need to be numbered out of public address space. So if you're doing over-the-top voice or video, great. If you're using one of the public services that's on the internet, that's an internet application. You probably need a public address to get there or some kind of transition technology, obviously. If you're doing in-house services, maybe it's not as required. So I decided I could exclude that. Your mileage may vary. There's a lot of your mileage may vary here. I excluded commercial customers because I couldn't find any way, even if I could find how many commercial customers a network has, I couldn't find any way to correlate how many addresses per customer they might be assigning. Again, too much variability. I just couldn't figure it out. I did explicitly, therefore, exclude the commercial AS for Verizon, for instance, because I knew that AS, I knew that's where it came from, but I can also let you know that I saw another 25 million addresses coming from AS 701. I also excluded the wireless business on the grounds that separate network, separate customers, highly NATed already, and LTE includes IPv6 support in the spec, and we're starting to see IPv6 support through LTE deployments. So probably not, I'm hoping, I'm arguing that wireless won't be a major driver of IPv4 address consumption in the future. Whew, more to go. For content sites, I picked some that I liked, that I said these are big content sites or CD, whatever they were, and I was looking, specifically trying to think about big and growing networks to see where they might be going, how many addresses they held. Again, kind of ran out of time. That's why I made it a lightning talk. Didn't have time to go back and look at the annual reports to figure out what their growth rates were. Again, did a bulk quiz, grep foo, and show me the net range, and then for each octet, multiply the third octet by 255 addresses, and the second octet by 255 by 255, and the first octet by 255 by 255 by 255. That's how I figured out how many addresses a network had. So here we go. This really surprised me. This was not at all what I expected to see. I would have thought Google, being a huge network, would have had a lot more addresses than that. It turned out that they have an awful lot of /29s swipped to them from ISPs. I did not know that. That's very educational. Facebook and Netflix, ridiculously low number of addresses assigned to them, but since I didn't get to the transit networks, I don't know if there may be some there that are being used by those, although I do notice that there's a CDN here that has a lot of addresses. And I'm not saying this is a bad thing. I'm certainly not impugning any network for how they're managing their network. I just want to point out, wow, that's a significant number of addresses. Maybe not even surprising, but one wouldn't expect that an organization with few addresses would be a major driver of consumption in an IPv4 address market in the future. And one other sort of exclusion here is the 560,000 that I listed for Microsoft does exclude the 600 whatever it was thousand addresses acquired from Nortel because they're not all routed yet. They haven't all been re-registered. So there's some hard to measure, hard to really get in there and figure out which addresses those were. So I left that out. So Microsoft does have more than that sort of in the bank. That's it. Shazam. That's very, I hope that's exciting and informative for people who are thinking about what the market, what the drivers might be in the IPv4 market in the future. Thanks.
Those were some excellent talks. We have two announcements before we break for coffee. First, I'd like to remind everyone that we will start back at 4:30. We are going to break out into tracks. We're going to do Network Operations Security track in Atlantis A and B. Air and Public Policy will be in this room, and the NOG Lab will be in Odyssey B. The second announcement is the afternoon giveaway for the survey. You have to be in the room to win. Is Brian from VeriSign in the room? Yep. Thank you very much. Thank you very much for the session, and we'll start back at 4:30.